We are the Inwerken group, and our project dealt with an augmented reality sensor logistics system. And our mentors from Inwerken were Leon Mueller and Radislaw Grabos. A little bit of background about Inwerken is that they're an IT consulting company based in Germany, and they do things like SAP consulting. SAP, if you don't know, is a type of business management software that helps coordinate and manage business activities and operations. They do project management for different kinds of software development. They provide service and support for their different projects and services and whatnot. And they work on Internet of Things. And they do that in conjunction with WSN Technologies, which is more the hardware side of the IoT. And WSN actually made the sensors that we used in our project. So our project team was kind of split into two teams. The first being the marker team, consisting of Wyatt Bloom, Ethan Nelson, and myself, Samuel Patton. And the interface team, consisting of Riley Moore and Alexander Lepper. So our schedule was kind of split into 4 sprints, like all the other groups. And our sprint 1 was just the project initialization. We didn't really get started right away on that one. We kind of didn't get started until like 2 weeks in. So that was kind of just familiarizing ourselves with each other, our mentors, and doing some preliminary research on what we wanted to use for the project. And sprint 2 is kind of the prototyping, kind of building our initial builds and designs of what we wanted to do. Sprint 3 was kind of working out some bugs and working on some main features to enhance the prototype. And sprint 4 was kind of finalizing it all. And during sprint 4, we also had to build a small Python application, which will be talked about in a bit. So kind of the main milestones for the 2 different teams was sprint 1, the marker team kind of decided on Viewmarks as the primary marker system. Viewmarks being kind of like augmented reality QR code, you can think of it as. Sprint 2 kind of consisted of working on the actual Viewmark design, getting that figured out and getting them working in Unity, which is what we used to develop the project in. And then sprint 3, we kind of ran into our main roadblock of the generation API for Viewmarks being a pro feature. Then we began working on the marker management application, which was that Python app, which just kind of generates Viewmarks that we can use. And then sprint 4, we kind of just completed all the features in the marker management application. And then for the interface team, sprint 1 was researching Unity and Vuforia, which is the library we used for the augmented reality part, and Viewmarks are actually part of Vuforia. And then sprint 2, they kind of worked on some interface designs and virtual button designs. Sprint 3, they kind of updated some of those designs, kind of had to rework some buttons. And then sprint 4, they kind of implemented the final version of those and kind of finalized Viewmark support within Unity. And the whole project opportunity for the project is working with Industry 4.0, which is automating industry with a lot of IoT devices or Internet of Things devices. So a lot of those sensors that we talked about, or that WSN makes, getting those installed in like factories or warehouses and whatnot. Some of the logistical difficulties with Industry 4.0 is kind of visualizing data transfer between the numerous sensors and a database and having it all update like it's supposed to and when it's supposed to. And the main reason for interest in Industry 4.0 is that it makes it easier to view information about different sensors in real time. So if you want to view information about a sensor on this shelf, instead of having to look up the sensor number and then go to the computer and type it in and search like that, you can just see it in real time as an overlay with an IAR app. And next I'm going to hand it off to Riley to talk about the general solution overview and the components of that solution.
So about halfway through the semester, we came to the conclusion that we were going to need to make 2 applications. This came from us acknowledging the fact that everything we wanted to do in the project would be nearly impossible to do in a single augmented reality application. Typing really isn't something that can be done efficiently in augmented reality. Because of this, while talking about our solution overview, we'll be covering the general features of each of the applications, and then we'll cover the most important, more specific aspects of each application. Starting with the marker management application, this application can be used by the user to create new instances of pre-designed markers. We'll explain what markers are in more detail later in the presentation, but for now just think of them as unique scannable identifiers, something similar to a QR or barcode. The reason why we didn't use a QR or barcode is because we were asked by Inwerken to use a more proprietary system that was more efficient to use in augmented reality, and as it would turn out, Viewforia has a Viewmark system which works perfectly, and we'll explain in more detail what those are later. There's currently a limited amount of customizability the user has when creating a new instance of a marker, namely they can choose between two marker templates, and in addition to this, the user can save local copies of the marker instances they create for printing purposes later in the augmented reality application. Moving on to the augmented reality application, this application is used to scan the markers mentioned earlier and display the information regarding their corresponding sensors. The interface that's shown to the user after they scan a marker has two distinct modes, a mode where only the immediate information about the sensor is shown, and a mode where both the immediate information and the historical information about the sensor is shown. This historical mode shows the states of the sensor from the last recorded 5 hours of its operation. In order to toggle the visibility of this historical information, the user simply needs to hover their finger over a virtual button. We'll describe in more detail what a virtual button is later, but for now just think of it as a button in virtual space that detects when it's obscured in any way, shape, or form by an object in real space. Moving on to the more specific components of our solution, we'll be going into more detail about Unity and Viewforia, Viewmarks, the design of the marker management application, the design of the sensor interface, and the virtual buttons. First things first, we'll be explaining what Unity and Viewforia are and how they relate to our project. Starting with Unity, it's likely that if anyone knows what Unity is, it's that Unity is a fairly popular video game engine. While this is Unity's main use case, it performs exceptionally well performing other tasks, such as rapid application prototyping, running simulations, and even training machine learning algorithms. For our project, we use Unity as the engine to run the augmented reality application. The main reason we decided to use Unity is because it works hand in hand with Viewforia, which we'll talk about in a second, and that, due to its core as a game engine, it enables for high levels of user interactivity. This is something we strive to include wherever possible in our augmented reality application. In addition, Unity also allows for a wide variety of backend features to be implemented in applications developed in it, which is something we needed as automation is a large part of the augmented reality application. In addition to this, Unity also scales reasonably well with the use cases of most applications developed in it. In regards to Viewforia, Viewforia is one of the most powerful commercially available augmented reality development libraries that we had access to. It's also natively supported by Unity, which makes creating applications using it even easier. While it isn't something that we were able to take advantage of for reasons we'll explain later, Viewforia allows its users to generate markers using their Viewmark Generation library, of which greatly enhances the scalability of our project, especially considering that Inwerken requested us to use a marker system that can scale to upwards of thousands of markers. Both Unity and Viewforia also have free personal development licenses, which is a bonus for us. Next up, Wyatt will be explaining the design rationale of the Viewmarks we ended up using for our marker system.
Alright. For the first sprint of the semester, the marker team spent some time trying to look online and find a marker system that would work within our application. We had a couple of different restrictions that this marker system had to meet. It had to have enough unique iterations of up to 100,000, so it had to have 100,000 different versions that it could be, and it had to be scannable from an extended distance, so like 15 to 30 feet is what the numbers that we were given. So we spent some looking online. We found a couple of different systems just here and there that we thought we might be able to use. Microsoft had an old version that they discontinued that we thought we could maybe repurpose, or there's a couple different things online, but eventually none of those worked, and we eventually came to find out about Viewmarks. Viewmarks are a marker system created specifically by Viewforia for the purposes of use in a Viewforia application. So exactly what we're trying to do. It allows you to design your own Viewmark template using your company's logo, and then can have as many iterations as you want it to. So if you set it to have 100,000 iterations, you have to have a certain amount of blinking dots, essentially. So we spent some time and came up with our first Viewmark design just towards the start of Sprint 2. And we came up with this design in Illustrator. We created it, and then we exported it, and we tried to set up a sample Viewforia application in Unity. and we tried using this Viewmark design for it, and it just wouldn't work. It wouldn't. The sample app wouldn't indicate that it was being scanned. It wouldn't. Nothing would pop up. Just nothing would work with the Viewmark application using this Viewmark. And so we tried, changing all these different settings. We tried using it this way and that way, and nothing worked. And then we eventually tried using a sample Viewmark in that same application from Vueforia's website, and that one did work. So that led us to believe that the issue lied with our Viewmark design. So we went and we did some testing. We came up with a whole bunch of different Viewmark designs to kind of test, figure out what the issue might be. At first we thought it could be, so how it does all those unique iterations is it has a black marker and a white marker, and depending on what the Viewmark ID is, it sets those indicators to black or white. And so we thought the first issue we thought it might be is with, the white ones have the outline enabled instead of just being all white. So we tried doing that, changed them to all white, still didn't work. We thought maybe those were too close to the border, the outside of the Viewmark. We thought maybe that was the issue, so we moved them in, put them on top of the Viewmark thing, to put them on top of the logo, like the one on the left there. Still didn't work. Thought maybe it was the colors, didn't work. All these different things didn't work until we eventually tried this one with the square border, and that one worked. So the conclusion we came to is that it is a problem with that circular design. It, for whatever reason, Vueforia just wouldn't scan it, wouldn't recognize it as a Viewmark. So we went back to the drawing board and we came up with what would become our final design. It's this nice hexagonal pattern. And because this is an asymmetrical design, Vueforia needed some way to tell what's up and down, when it's facing up, when it's facing down. So we added these little dots right here to indicate that to Vueforia, and this one works, and it has up to 100,000 unique iterations. The one on the right uses Inwerken's logo, and then the one on the left uses their sister company WSN's logo, and we changed the colors to match them. And yeah, it gave us that 100,000 unique iterations that we were looking for. It also gave us the kind of scanning distance that we were looking for. And it just works very easily in Vueforia since it's designed to. So this is our final Viewmark design. Now the way that the Viewmarks work is the Viewmark, so Inwerken or WSN will send out these sensors to the user, the customer. They'll send them out the sensors and say the customer will get, sensor number 127, or they'll get sensor number 245, and so they need to then get the Viewmark with that same ID to go with that sensor, and then they'll be linked together. So there were a couple ways we could do this. Either Inwerken could go onto Vueforia's website and generate them when they needed them, just one by one, but we didn't think that sounded like a very good system, so we decided to come up with a secondary application using Vueforia's Viewmark Generation API. And so we did. We came up with this. We got this application that we'll go more in depth on it a little later, and have a demo that kind of just shows off what exactly it is that it can do and all the different features that we included in it. But it uses Vueforia's Viewmark Generation API on the back end of a tkinter Python front end. The tkinter is a GUI framework built into Python. So yeah, we came up with this. This is what it looks like, and we'll talk about it later with the demo. But for now, I'm going to pass it back to Riley to talk about the interface design.
While talking about our sensor interface designs, we'll walk you through the history of our interface designs and the decisions that led us to our final design. Our original interface design was largely just a test to see what information should be shown to the user immediately. Ultimately, this design has influenced our final design, and you'll notice recurring features from this design in future designs. The main points of interest for this design is the interface header, which depicts the identification value of the corresponding sensor and the material that sensor is tracking. In the bottom half of the interface, you'll notice status bars depicting the battery life and signal strengths of the sensor with associated percent values. Below, there are the additional states of the other trackers found within the sensor. This interface featured a mock button that was planned to show the history values of the sensor, but this feature was never realized in this design. This design was also created before our marker system was officialized, hence the playing card being used instead of a marker. The next design we attempted to use contained all of the same information found within the original design, but just in a different layout. This design was created in the early stages of marker development, and it attempted to mimic the circular shape of the marker we were using at the time. This design was ultimately rejected due to certain aspects being too large, such as the battery life and the signal strength indicators, and others being too small, such as the other tracker states. The next design we developed returned to the roots of the original design, just with more polish. This design was created in the early stages of our virtual button implementation, and it was therefore able to feature the ability to toggle the visibility of the history graphs. The main issue that was found with this design was that the graph text was generally too small to read easily, though. Another issue, albeit one that was unknown to us at the time of creating this design, was that virtual buttons require their own marker to work. There's no exceptions to this rule. Therefore, that View History Summary button at the bottom of the interface didn't work. That button was located directly on the main marker. This caused a variety of issues, though, namely the fact that attempting to push the button often caused the marker to be lost by the augmented reality application, which then resulted in the interface disappearing from view. Our penultimate design sought to remove the need for a virtual button to toggle the visibility of the history graphs by simply displaying the history graphs immediately after the marker was scanned. This design never got out of the prototyping phase, however, as Inwerken really preferred the interactivity that the virtual buttons provided, and honestly, we did too. This was largely the catalyst that caused us to spend a significant amount of time finding a workaround to solve the issues of our older virtual button implementation. Our final interface design used our third design as a base and built upon it. The new main features included in this design were more easily readable history graphs, an interface color changing feature, of which is used through a configuration file, automatic language setting, of which detects the language being used by the device running the application and setting the interface text language appropriately, with English and German currently being supported, and our final virtual button implementation. This final implementation revolves around the use of a marker dedicated to the virtual button, which largely resolved the issues caused by the original virtual button implementation. The main downside to this new virtual button implementation, however, is that only one sensor marker can be visible on screen. This is the result of Euphoria allowing only one instance of any marker to be scanned on screen at any given time. Next, I'll be talking about how our sensor interfaces are automatically generated when a marker is scanned. Before going into too much detail about how the interface is generated, it's necessary to understand what Unity's prefabrication system is. Prefabrication can be thought of as a form of cloning. One object can't be in multiple places at the same time, and the most simple way to go about solving this issue is creating another of the same object while using the original as a template. The newly created object can then be modified and used however we see fit. For the sake of this explanation, consider every image on the left side of the screen to be a prefabricated, or cloned, object being created to form an entire new interface. Now, when a marker is scanned by the augmented reality application, the corresponding sensor's information is pulled from a mock data file. We'll go into more depth on this process in the next slide. It should also be noted that the use of mock data files is present in this final build of our application, but was planned to be removed in favor of pulling data from an actual database. We'll go into more detail about this issue later. Once the sensor's information is pulled, the amount of needed sensor component is determined, and the interface can be generated. First, an interface top, header, and body component are created as every interface requires one of each. Then, the needed amount of sensor components is created, and an interface bottom component is spawned to cap the interface off. All interface components are aligned as necessary using a snapping system we created within Unity, and the interface for the scanned marker is now generated. When it comes to displaying the text and values on the generated interface, as previously mentioned, the values are pulled from a mock data file. These values are then sent to a data parser, which largely just isolates the data found within the values, removing any unnecessary characters. This parsed data is then sent to a data formatter, which ensures the values are structured properly. This involves things such as the first word of any string being capitalized, decimal values being converted to percent values with a percent symbol and the like. The data formatter then calls our translator to ensure any displayed text is shown in the correct language. This translator's functionality was described in a previous slide. And finally, the translator sends the finalized values to the interface generator to set them in their appropriate locations. Next, Alex will go into detail about what virtual buttons are and how they function.
Our application uses virtual buttons to toggle the graphs on the sensors between shown and not shown. To do this, we use Vueforia's virtual button system, which overlays a little box over an image target, and every sensor point in that box must be covered to trigger the button script. We didn't originally want the button to be on the actual marker. We wanted it to be below on the interface, but you can't use the virtual button on the interface as there's no image targets to view. The image target thing was also a problem because view marks are not technically image targets, so you can't add buttons to them. To work around this, we created a second image target that just says press button, and we now append that to the actual view mark when it's printed. So this would be below the view mark, you'd press the little press, and then it would toggle the graphs. Now we'll move on to application demos with Sam showing off the Python application and Wyatt showing off the actual AR application.
So this is our Viewmark management app that we wrote in Python, and the whole purpose of this app is to automatically generate new view marks when you need them. You just enter a sensor ID or a range or whatnot. You can save them. So this is actually the Inwerken view mark right here. This is the Inwerken's logo in the center. And you can also change to WSN view marks. And just a heads up, the file and the marker, those menus aren't displaying on the capture software I'm using. So this is a WSN view mark. And the marker just has a list of, you can choose Inwerken or WSN. So we'll go back to Inwerken right now. And what you can do is you can either save a single view mark, like here, you can enter a sensor ID, save one, you can save file. And what it does is it just pops up in your file explorer, which isn't being captured by the recording software I'm using. And you can just pick a file, hit save, saves the computer. You can do the same thing with, say, a range of view marks, and say 1 through 3 or maybe 1 through 9 or whatever. Click save file and it just pops up in the file explorer and it saves it just like that. And you can also do multiple. You just enter different IDs separated by spaces or commas, and it'll put those in a folder that it creates called view marks, and then save that folder to your computer. Now, because Inwerken is a German company, we needed some kind of language support. So if you click file and language, you can choose between German and English. Translates just like that, nice and easy, no problem. And then back to English. A couple things about the back end of this app is it's written using tkinter, which is a Python GUI library. And in tkinter, if you don't carefully plan out the code beforehand, it can quickly become spaghetti code, because for the structure of the actual app and the buttons and the layouts and the images, it's all based on frames and that you declare, and then you have to declare objects and then assign objects to frames and assign frames to the root. And if you don't plan that out from the beginning, it will quickly spiral out of control and become unusable. So Wyatt actually had to spend quite a few hours refactoring all the code and cleaning up all the assignments of frames and objects and the root. And then one final note about this app is we don't have the Vueforia Pro license, so we can't automatically generate new view marks. So every view mark this app creates is just the same view mark with a different ID. And there's nothing we can do about that without the license, which you have to pay for. So that will be something for maybe a future group to do, or maybe for Inwerken themselves to do if they decide to get the Pro license so they can generate new view marks.
Alright, so I'm going to do a little demonstration here of what the AR application will look like in the real world, what kind of use case it'll have, and also demonstrate some of the features that it has and what it'll be used for. So I kind of set up a little display thing here, like a mock, like in a warehouse, you got like shelves of inventory and stuff like that. That's the best I could do. So these are the sensors that are sent to us by WSN. They have a little sensor data here. Let's stick it against the thing, but have activators. And so basically what will happen is these will be like on your warehouse shelves like that.
and you'll have your boxes of inventory placed on top of them, like so. And then, so say for example, this is sensor number 1, and that one over there is sensor number 2, or is it the other way around? Yeah, so this is sensor number 1, that's sensor number 2, and then we have attached to our inventory boxes Viewmark number 1 and Viewmark number 2 over there, and so they, in the application, they will connect to the sensor data, or the application will connect to the sensor database, and once you scan a Viewmark like this, it will send a query to the database that will get the sensor data that's being sent to the database, and it will display it here. So as you can see, this sensor number 1 is connected, or Viewmark number 1 is connected to sensor number 1, and it's able to get, since to the sensors, it gets all the data that's being sent out the sensor. This is just mock data. We weren't able to connect our application to the database this semester. It wasn't one of our, not something we had time for. They were doing some updates to their stuff. So this is just mock data. But as you can see, it says sensor 1 and sensor 2 because this sensor here has got these two separate sensors, or two separate activators. That is dynamically updating, so depending on what sensor you're looking at or what information you're receiving, it will display it. And the lighting's not the best in here, so it's kind of hard to scan the markers. But as you can see now, this one just has the one sensor, so it just says sensor 1. It doesn't say sensor 2, and it doesn't say, anything that's not there. So depending on what information each sensor sends out is what will show up in this UI. And as you can see too, this is unit number 2, and the mock data they gave us, this one would be set up connected to cases, and then this one over here would be set up connected to screws. So what happens when it scans this Viewmark? Early on, we were trying to set up, before we had the Viewmarks finished, we set up, we used like a sample image, and we created this whole user interface based around an image target, which is just a sample image. It's fundamentally different than Viewmarks, so they operate in different ways. At the time, we didn't know that, and we set up this whole UI, the whole method of which we use the virtual buttons. We set that up using image targets early on before we had the Viewmarks finished. And so then once we got the Viewmarks finished and we went to integrate the two systems together to put the Viewmarks in place of the image targets, we realized that virtual buttons don't work with Viewmarks. They you can't, if you're going to put a virtual button anywhere on here, you're going to be blocking up some of these sensors, so it won't be able to tell which ID you're looking for, Viewmark ID. So our solution to that was to add an image target, basically concat an image target to the bottom of our Viewmarks, and then once it scans the Viewmark, and it'll also scan the image target, and it'll put the virtual button on top of that image target. So then once the virtual button is pressed, it gets the extended graph information, and it displays it on top of the UI that's already there. Oops, from the Viewmark. Yeah, lighting is a little tough out here, so it's kind of hard for it to scan both objects. But so as you can see, and the other thing that we weren't able to implement this semester just for time reasons and whatever else is because extended image tracking. So basically, once it loses an image target, it degenerates the whole interface, and so it's just gone. And then once it scans it back in, it regenerates it. So with extended image tracking, it won't go away. It'll stay there. And so then when you come back to it, like so, for example, I scan it here, and it pops up, and then I move my phone away, it doesn't disappear like that. It still stays there. So when I move it back like this, it's still there. And so that's something in the future that they're going to have to implement if they want to use this long term. And it'll solve a lot of the issues that you're kind of seeing today. So once we scan it here, we press the button. We have some, here we go. We have some we have sensor history data graphs that will pop up showing so like this one over here shows the battery percentage over time as it's slowly going down. So 90% now, an hour ago is at 80%. And then over here we've got the sensor history that shows when it's active and inactive. So basically if one of these wheels is up, it's inactive. If it's down, it's active. As you can see here, we've also got that listed here, active or inactive. And then this is, so sensor 1 and sensor 2. This is also dynamically updating. So depending on how many sensors you have attached or how many little wheels here you have attached to this sensor, it will show the necessary information. An example of that, we come over to this one, scan this one, press the button. And then, oh, lights went off. Doesn't help. And then now, as you can see, it's just got the one sensor data over here, or sensor history graph over here instead of the two, because there's only one wheel on this sensor. And then also you can see it only shows one sensor status. It updated the height of this box and it put in all the necessary information. The other feature that we wanted added in this application was multi-language support. So because Inwerken is a German company, they speak German over there, so we added 2 languages so far, English and German. And early on, what we did was we had a button up at the top of the screen that you could tap to change your language. However, we didn't, and the reason that we also wanted virtual buttons instead of actual physical buttons on the phone screen is because we wanted this to be usable on AR goggles, and those won't have like a touch screen that you can press buttons on. So we want everything to be hands-free and touchless, touch-free. So we added the virtual buttons, and then depending on your phone's default language, it will set the language of the text here, depending on what obviously your default language is. So if your phone's in German, it'll set it to a German, and if it's in English, it sets it in English. Yeah, so that's what the UI looks like.
Over the course of the project, our team encountered a few notable issues. During the initial stages, we lost the file for the original Viewmark design. This meant we had to remake the design using a picture we had shared as a reference. Another issue was transitioning to Viewmarks had several unforeseen challenges, including a few requirements for designing Viewmarks that we didn't know about, as well as several problems getting the Unity application to work with Viewmarks specifically. One of the original requirements was to make the program able to run on an AR headset. Unfortunately, due to the high cost and our team's current distance from NDSU, we never were able to get one for testing. Another last problem was the subscription, which when our team initially chose to use Viewmarks, we understood that the final product would require a subscription plan. However, we didn't realize that we wouldn't be able to use the Viewmark Generation API, so we were never able to test that. This is the percentage of time spent for each of the teams on each part of the assignment. Here's some information and next steps. All right. Finally, to end the presentation, we will briefly go over some of the next steps for this project. The next team that works on it. First, a professional license will need to be purchased for the Viewmark Generation to work. The Viewmark Generation will also need to be tested. Some changes will probably need to be made as well. Next, the servers will need to be connected to the application. Up to this point, we've just been working with some set data. It doesn't change, so that will need to be tested. Image tracking will need to be improved. Currently, the effectiveness drops dramatically with movement. The distance could probably also be increased. Lastly, the application should be changed to be able to scan multiple Viewmarks at once. Currently, you can only scan one at a time, and that's
that could definitely be improved upon. Thank you for listening.